This video is for Notes 8-1, starting with the bell work on the front page of your packet. For problem 1, they ask us which inequality describes all the solutions to 5 parentheses 3 minus x close parentheses is less than 5. So the first thing I'm going to do is distribute. 5 times 3 is 15. 5 times negative x is negative 5x. And the less than 5 stays where it is. From here, I'm going to move the 15, so I subtract 15 from both sides. So negative 5x is less than negative 10. And then divide both sides by negative 5. So x, flip my sign because I divide by a negative. And then negative divided by negative is positive. So x is greater than 2. We can automatically mark out C and D because those have negative 2's, and then the sign that matches is answer choice B. So on our notes for today, we need to recall that inequalities with one variable, so one letter, can be plotted on a number line, such in the case of x is greater than or equal to 2. So that is the solution that we just had. X is greater than or equal to 2. Because there is a line under my inequality, I'm doing a filled in bubble. Remember, if they took the time to write the line, you take the time to fill in the bubble. Greater than 2 would be numbers like 3, 4, 5, 6, 7, 8, 9, and 10. So it would be anything 2 or more than 2. The solution to an inequality is a point which, when substituted in for the variable, makes the inequality a true statement. In this case, the points C, D, and E are all solutions because they all fall underneath that inequality. 2 is greater than or equal to 2. 5 is greater than 2, and 10 is greater than 2. So there are multiple points there. So when we deal with inequalities, we are dealing with a range of solutions, not just one specific solution. Now, if you have inequalities with two variables, an x and a y, they need to be plotted on the coordinate plane, such as the case of y is greater than or equal to x. So this line is already drawn for us. This is y is greater than or equal to x, and it's shaded to show us if we plug in, well, we're going to hold off on that. So the shading tells us where my solutions would be. Y is everything greater than this line. Greater than y would be above the line. So in this case, the points A, B, and C, A is here, B is on the line, and the line is included, and C is right there. All of those are solutions because for each point, the y value is greater than or equal to the x value. The shaded region is also known as your solution region because all of the points in that solution set, in that shaded area, are solutions to the inequality. So when we graph our inequalities, we're going to follow these 3 steps. If necessary, solve for y. Once we've solved for y, we're going to graph our y-intercept and our slope, and we're going to use a line. It's going to be a solid line. You need to make sure you make this differentiation on your paper. Solid line if we put a line under the inequality, or dashed if there is no line under the inequality. So what I remember, if they took the time to write the line, my line needs to look like this. If there is no line, then it's going to look dashed. So there's no line under the inequalities here. And then we're going to determine our shaded region. So for problem 1, my m value is negative 2, and my y-intercept is down at negative 3. So 0, negative 3 is where I start, where I begin. My slope is negative 2, so down 2, right 1, down 2, right 1, down 2, right 1. This is going to be a solid line because of that line underneath the inequality. And then to figure out my shading, I am going to ignore the x and just rewrite all of this with my y and my y-intercept. So I'm ignoring anything attached to x. So y is less than or equal to negative 3. Y is less than or equal to negative 3. Numbers less than negative 3 would be negative 4, negative 5, negative 6, negative 10. So where I've shaded, we're going to shade all the way underneath that line. So using your y-intercepts, you can come up with your shading. Once you have the shading on the y-axis, then fill it in underneath the line. So for problem 2, we still start down at negative 3. My slope is 1/2, so up 1, right 1, up 1, right 1, up 1, right 1. This one is a dashed line because of my inequality. They do not have a solid line under the inequality, so I will not have a solid line on my graph. Now again, for shading, I just look at y and my y-intercept, I ignore the x. So y is greater than -3. Things that are greater than -3, -2, -1, 0, 1, 2, 3. So where I've shaded on the y-axis is where I will shade on the whole line. I use the y-axis to help me determine above or below, and then I shade all of that on my graph. So for problem 3, we have the graph where our m value is 1 because that's the number in front of x. Our y-intercept is 0, -4 because that's where it starts for b. I start down at -4, up one right, one up, one right, one up, one right, one up, one right, one, just a couple times. This is going to be a dashed line because there's no line under my inequality symbol. And then for my shading, I ignore the x. Y is greater than -4. Greater would be anything above -4, so that's where I shade for the rest of the line as well. Problem 4, my slope is -2/3. My starting is at 0, 5. So I start up at 5 and go down 2, right 3, down 2, right 3, down 2, right 3. This is going to be a solid line because the inequality symbol with a line underneath it shows me what type of line I'm going to have. And then for my shading, y is less than or equal to 5. Less than 5 would be anything below 5. So below my line is where I'm going to shade.